independent and dependent variables. When we're working with equations with two variables, one of the variables is the independent variable and the other variable is the dependent variable. The independent variable is not affected by the other variable. The dependent variable, the value of the dependent variable, is affected by the independent variable. Its value depends on the independent variable. When we graph dependent and independent variables, we graph the independent variable on the x-axis. It is also known as input and the domain. The dependent variable is graphed on the y-axis. It's known as the output and the range. So let's determine the independent and dependent variable in this example. We have an example of the volume of water in a pool versus time. Time is the independent variable. The volume of water in the pool, or how much water is in the pool, is the dependent variable. So I'll give you two different examples here. In the first example, let's talk about filling the pool with water. So we start with an empty pool, and as time increases, the volume of water, or the amount of water in the pool, increases. The volume of the water is dependent on the time. The more time passes, the more water in the pool. Another situation is when we drain the pool. Draining the pool. We start with a pool full of water, and as time increases, the amount of water in the pool decreases. But still, the volume of water is dependent upon time, whether we're filling the pool or draining the pool. Here are two different variables, the amount of paint in a can versus the area painted. The area that's painted is independent. So it goes on the horizontal axis, the x-axis. The amount of paint in a can is the dependent variable. The amount of paint I have in my can depends on how much I've painted. So I start with a full can, and as the can gets empty, the amount that I've painted increases. So as the amount of paint in the can decreases, the amount of area I've painted increases. Final example, example 3, iTunes is having a special sale. For every 2 songs you buy at regular price of $1.29, you get a third one free. So in this example, we're going to create a table of values that represents this, and then we're going to graph that. The x values are our independent variables, and our y values are our dependent variables. So if I purchase 1, 2, 3, 4, 5, 6 songs, that's my independent variable, is the number of songs. Y is my dependent variable, is the cost. How much it costs me depends on how many songs I buy. So if I purchase one, it's $1.29. If I purchase two, it's $2.58. Now that they're having a special sale, every 2 songs I get one free. I get the third one free. So when I purchase the third one, I get it free, so I'm still only paying $2.58. If I purchase a 4th song, it'll be $3.87. If I purchase a 5th song, it'll be $5.16. Every 2 songs I buy at a regular price, I get the third one free. So here I bought 2, got that one free, bought 2, I'm going to get this one free. So my 6th song is going to cost me the same as my 5th, $5.16. So here's how we represent it in a table of values. Now let's represent it on a graph. X is 1, Y is $1.29. X is 2, $2.58. X is 3 is also $2.58. 4 songs goes up to $3.87. 5 songs goes up to $5.16. And 6 songs is at $5.16. All right. You can see that these are just dots on the graph. They're not connected. They are considered discrete, individual items. It's not a continuous line. It's called discrete graph because I can only purchase whole songs. 1, 2, 3, 4. I can't purchase a half or 7/8 of a song. So when I graph it, I graph individual points. That's called a discrete graph. If they're connected, it's called continuous.